Good morning and hello. Today we're going to be going over measures of spread. Let's adjust that camera a little bit. First up, we have range and interquartile range. Statisticians use measure of spread or the variation to describe how widely data values vary. One such measure is the range, which is the difference between the greatest value and the least value of a data set. So you take your largest number and you subtract the lowest number from it. You have quartiles. Divide a data set arranged in ascending order into 4 groups, each containing about 1/4 or 25% of the data. A 5-number summary contains the minimum, quartiles, and maximum of a data set. So 5-number summary is something we're going to have to be doing today. All right. The median marks, we're back to median. We know what median is. The middle value marks the second quartile, or Q2, that separates the data into upper and lower halves. The lower quartile, Q1, is the median of the lower half. The upper quartile, Q2, is the median of that upper half. So the way to think about it is once you find the median of your data, you are able to then, from the median, find the median of the top half and the median of the bottom half. A box plot, or a box and whisker plot, I learned it as a box and whisker chart or a box and whisker graph, is a graphical representation of the 5-number summary of a data set. A box is drawn from Q1 to Q3 with a vertical line at the median. This box represents the interquartile range, or IQR. So interquartile range, which is the difference between the upper and lower quartiles. The whiskers of the box plot are drawn from Q1 to the minimum and Q3 to the maximum. So we find the median first, and then we find the middle of the median to the lowest value, and then we find the middle from the median to the highest value, and that gives us our Q1 and Q3, and the interquartile range is the positive difference of that. What is the range of the scores? Arrange the data in ascending order. Now, if you're just determining the range, the main reason for doing data in ascending order is just to guarantee you have the smallest and lowest value. So let's see, they started arranging for us, so let's cross out what they already have. I see a 70, I see a 79, I see an 83, I see an 88, I see a 91. So what we are left with is 62 as our minimum and 99 as the maximum. So to determine the range, we're going to do 99 minus 62. So 6 to 90 is 30, and 2 to 9 is 7, so this will be 37. Ordering. Because the range involves only the greatest and least value in a data set, it can be determined without ordering. Hey, I just said that. However, it is often useful to order the data to avoid missing a number. That's right. You could miss a number, so you want to be very careful. And with math like this, if you choose the wrong number, you just get the whole thing wrong. Example 2. A financial analyst for a movie studio wants to determine how much most of the top earning movies have grossed to compare his studio recent grosses. All right, so he's comparing what he's making to how much the other top studios are making. Got it. The worldwide grosses in millions of dollars for the top 10 highest grossing films of all time are given. Determine the 5-number summary and draw a box plot of the data to see the spread of the data. Now, we are lucky Desmos will do this for us, the 5-number summary. It can do a box plot, but since we have to construct these by hand, it's easier to do the construction part by hand and to use technology to get our numbers. So, following their guide, part A, determine the 5-number summary. So the first thing they did is they arranged the data in ascending order. All right. From here, we determine, since we have 10 pieces of data, that means that we are going to have our middle value be the 5th and 6th value. 10 is an even number. So we have to take the average of these two. From here, we can find that 1,342 will be our Q1, because that's the middle. And then the middle on this side. Oh, not that one. This one. Scribble out that. The middle over here, we have 1, 2, 1, 2. So this is our middle, and this is our middle. Determine the 5-number summary. So we take a look. We have our minimum. We have our Q1. We take the average to find the median. That's our Q2. There's a typo here. This should be Q3. Q3 is 206, and the maximum. Q2 is right there. So now we have to construct a box plot. The first step is to construct a number line. Because the minimum value is 215 and the maximum value is 278, your number line must include those values. So this is where we can we are not being very exact on this number line. We're trying our best to put the numbers where they are, but we want to get this scaled so it's reasonable. Since we're dealing with a 4-digit number, they use the first 2 digits as the main point, and then we are eyeballing where those data values should be. Draw and label a box, because the minimum value is 1215 and the maximum value, okay, must include those. We got that. Draw a box. Wait, we skipped a step. We have to plot the values. Construct a number line, include these values, draw a box. We're not drawing a box yet. We have to connect the dots. All right, so we got to add a step here. After you construct a number line, mark min, Q1, the median, Q3, and the max on number line. All right, so now that we've marked them, we can draw a label a box from Q1 to Q3 with a vertical line at the median. All right, so we made a box. Draw the vertical line at the median. Then we draw whiskers, draw a line from the minimum to Q1 and from Q3 to the maximum. Marriage. The average age at which a woman first gets married differs by country. The age of each countries are shown. Select the box for the data. All right. So they've given us these 5 values and we have to match them here. So what I'm going to do real quick is we're going to pull up Desmos and show you how Desmos gives us a 5-number summary. Load Desmos. So we're going to make a table, and the reason why I'm making a table is we can just add values and it goes down, and we can use the X1 as our list. We could use list notation. This is just a quick way of doing it. Our values are 25, 26, 21, 27, 31, 31, 29, and 20. From here, I'll double check, 25, 26, 21, 27, 31, 31, 29, 20. Awesome. The command we're going to use is called stats. And then we're going to highlight x1, x subscript 1, and paste it right there. And voila, we have our 5-number summary. This tells us our minimum is 20, Q1 is 23, the median is 26.5, Q3 is 30, and the max is at 31. All right, so we need 26 for our median, 26.5. Well, it can't be this one because this one has the median at 29. A is out. And the failure is we have a median at 29. B, let's see. Median looks 26, 27. It's at the halfway point. All right, median checks out. Minimum 20, that checks. 23 is the Q1, that checks out. 30 is our Q3, that checks out. Maximum is 31, that checks out. The answer will be B. If we take a look, D is out because D doesn't have the minimum and maximum values plotted. And if we take a look at C, let's see, it goes 20 to 31. Oh, here we go, look. Our Q1 value is off. It says Q1 is 24.5 instead of 23. Interquartile range. Sarah wants to upload a song that she recorded and share it with her friends. She wants to know whether her song, which is currently negative 12 decibels on average, is the right volume compared to other songs online so listeners do not have to adjust their volume. She writes down the average volume of 7 songs. Find the interquartile range of these volumes. All right, we don't need Desmos for this, so let's turn that off for now. So we have our data values. They've ordered them. There's 1, 2, 3, 4, 5, 6, 7 values. So if there's 7 values, that means the 4th point will be our median. Then from there, we see since we have our median here, the middle will be 18. We have a middle here. And if you didn't catch it, the numbers look like they're going from greatest to least, but they're negative, so that goes opposite. And we have our minimum and our maximum. All right, we have our 5 numbers. Determine Q1 and Q3. We took care of that. We have Q1, the median, and Q3. Notice that there was a difference here. This one had an odd number of values, so the median we calculated, and then after that we look at the data with the median blocked off, whereas on the front page that we worked on, this was an even set of data. Our median was here, this line is where the median is because you had to calculate it, and then we look at the halves to find the next part. So our Q3 is negative 13. That's written down. Our Q1 is negative 18. Since we are adding the opposite here, this will be negative 13 plus 18, which gives us 5. So that says the difference between Q1 and Q3 is 5. Interquartile range is always going to be positive because it's telling you how far apart they are, and distance is normally positive. You can't really have negative distance. Writing. Cora is writing a novel and tracks the number of pages she writes each day for a week. The number of pages she wrote each day for a week is shown. Find the interquartile range of the data set. All right, this is a real easy one to order least from greatest, but I would like to continue to show how to use Desmos support here. Desmos is allowed on all of our standardized testing and is built into our calculators. All right, so where is it? Oh, not calculator, our Chromebook. All right, here we go. So first up, we're going to remove our data. All right, we're down to our front piece, so we'll enter 6, 5, 0. And notice, just like with mean, median, and mode, the stats update with each piece of data we enter. All right, so first up, I have 1, 2, 3, 4, 5, 6, 7 pieces of data. 1, 2, 3, 4, 5, 6, 7 pieces of data. All right. 650, 650, 3814, 3814. We got it. All right. So min is 0. Let's Q1 is 1. The median is 4. Q3 is 6. And the max is 8. So the interquartile range will be Q3 minus Q1. So we have, so that's going to be 6 minus 1, which is 5. Standard deviation. All right, this is another one that Desmos can help us with. All we have to do is pull up the not 5-number summary. We type standard deviation into Desmos and it'll calculate it. In a data set, the standard deviation shows how the data deviates from the mean. A majority of the data in a set, approximately 2/3, is contained within one standard deviation below and above the mean. So if two data sets have the same mean, but one has a greater standard deviation, then the data set is more spread out. So standard deviation just tells you the spread of a data set. Grab a drink real quick. So to find the standard deviation, now this is a process, and back when I was in college and high school, all this was done by hand and the only aid you got was a calculator to add up your sums. Prior to that, you had to do the whole thing by hand, and this is why stats took so long. Technology has made this remarkably easier. Find the square of the difference between each data value x sub n and the mean mu. So this is mu. We use x bar, which is the same as mean, and we use the Greek symbol mu. Now, x of n, this is referring to your data points. If you look here, you have x1, x2, all the way to xn. So that means each individual piece of data, we're going to take the mean, subtract that piece of data, and square it. And then we have to find the sum of all those values in step 2. So after we do this, for every value, we add it up, divide the sum by the number of values in the data set. This is the variance. Variance is very important in statistics. We take the square root of the variance and we get standard deviation. I believe, yep, there we go. So the symbol we use for standard deviation is, what symbol was that again? Give me a second to recall. Oh, that's not rho. Is it mu? No, that was mu is that one. I don't remember which one it's called. So this is our standard deviation symbol. Calculate the standard deviation. The number of students accepted at the main campus of each university in the Big Ten East divisions are shown. Find and interpret the standard deviation of the data set. All right, they gave us 1, 2, 3, 4, 5, 6, 7, 7 values. Find the mean. We see them add them all together and divide by 7. And if we take a look, it tells us that the answer is 19,774. Sorry, 19,747. Dyslexia kicked in there for a second. After that, you have to find the difference of the average minus each value. So from the first, second, third, fourth, fifth, sixth, seventh, we square each one and we get these values. The last two they're asking us to do ourselves. All right, let's grab our handy dandy calculator. You can also use Desmos to do the calculations. So this is 19747 minus 25772 squared. Up, one too many. No, 19747 minus 25772 squared. Yep. And we get that big number. So 363000625. 197, that's not a 7, 747 minus 18230, and then I'm going to square it. 2301289. Then we add all these numbers together, and you see that they do a summation, they do the dot, dot, dot. That just means that we're adding them all together, and they're cutting it out for ease of space. We see that the value is 176982773. And then we have to divide that by the number of values. All right. 176. Oh, they give us the answer right here. It's approximately, well, let's include these decimals. I want to see how they rounded that. 176982773 divided by 7. So we get 25283 and then we have a 0.29. So they rounded that to 0.3, and I'm not, that actually is, I don't know. We'll plug this into Desmos and see what Desmos calculates at the end, because we just cut off something, and when we take the square root, it might alter our answer a little bit. So from here, we got to take the square root of 2528325325283 Double check. 252833253, and its square root gave us 5028.245519, or approximately 5028. Now let's plug this into Desmos real quick. Interact. First, let's see if we can get the command. S dev, no. one quick second to look it up. It's STDEV. STDEV. There we go. And then we're going to copy that X1 into that to get our answer. All right, so now let's get rid of this data. We're back to our first value. We have 27300, 12333, 15570, 21610, 17413, 25772, 18230. 1, 2, 3, 4, 5, 6, 7. All right, and it says, oh, that's a little different. Did I type a number in wrong? Let's take a look. 27300, 12333, 15570, 21610, 21610, then 17413, 25772, 18230. That's interesting. Let's find the sum. Something's going on here. So I guess we should find the mean. It says the mean is 19746. Oh, here we go. So the mean here is 19746, and they rounded it to 19742. The problem is this says equal right here. So we have an issue where we rounded our mean, and then when we used that rounded number, it's affected our overall answer. So this is one of the problems with statistics. Your answer gets changed based on how many significant figures you used. That's a little concerning that it just rounded to one decimal, because we see right here that our mean is 19746.8571, and the standard deviation here is this. Honestly, you should use Desmos to get the answer, because that is going to give you the exact answer. These roundings here are a little problematic. God, I hate using that word. If another data point less than 14719 or greater than 24775 is added to the data set, how would that change the standard deviation? If you add one bigger, it slides this way. If you add one smaller, it slides that way. And that's the end of our notes. All right, so for standard deviation, I would 100% use Desmos to calculate this. I'm not sure how the answers are going to work on the online platform. We'll make sure to check that out. But Desmos cannot give you a wrong answer, and as long as your data points are put in correctly, the answer you put should be correct. And I will go in and check if need be.